These Jabra 65E are terrible. They have the noise cancel on them crackles after a week or two. So when you have it on, it shoots out bursts of static into your ear. Genuinely awful product. So today we are going to get started working on a MacBook. Let's get to work on this MacBook. Let's see what we have in the queue for today. What? Well, no, I gotta know. The suspense is gonna kill me. Be right back. Company business. 1 minute.
Get that back, it'll have to be fucking...
Sorry about that. So we had to let an employee go, and my payroll company decided to continue paying that person throughout the next pay period, and then said that we never entered into the little field that we had let them go, even though we have 2 copies of emails that we sent to these people saying let this person go, and I have a recorded phone call saying, oh, so you're terminating this person? Yes. Okay, we'll do that for you. So this is the last week they'll get paid. We're terminating them. So we sent them the copy of the recording, and they're like, I'm just dealing with the incompetence of the... This is like too much for a week. Oh, I'm going to pick up your packages. I'm just going to lose all of them. I'm going to do your... Oh, yeah, I'm just going to take $2,000 or $1,000 out of your bank account and just give it to this schmuck. No offense. You're not a schmuck. Although with the glasses with the tape on them, it kind of...
It's hot glue.
You know how many people yesterday are like, do you pay this person? Does he just work here for food? Because he can't even afford to get new fucking glasses.
It's time to go to an eye doctor.
Go to an eye doctor. I'll pay for it.
I have insurance. I just don't have the time.
Wait, you have insurance? I don't even have insurance.
Through my mom.
Wow. The guy with the taped up glasses has better insurance than the business owner. Anyway.
Still a child.
Alright, he says it through his parents. So let's go over this machine. Back to where we were before that. It's not even dealing with idiots. I'm used to dealing with idiots all the time, but I would like to not. But when they have direct access to my money or my stuff, that's when it just starts to get. And they continuously do it. Like, we are held to a standard that I'm not allowed to hold anybody else to, and I think that's part of what's bothering me. If I lose 5 or 10 or 20 customers' things, they will take an X-Acto knife, and my testicles are just they're just gonna be hanging from the window. There's no other way to say it. If I take $2,000 of a customer's money and just dispose of it to somebody, they will take my testicles and they will slice and dice and drain the blood and then hang the skin on the window. I can't do these things.
We don't send back a cable and people flip out.
Yeah, like, we don't send back a hard drive cable and people flip. So let's say that somebody sends in a drive for data recovery. We recover all their data that drive savers wanted $5,000 to $10,000 for. We recover their data for $700 to $900. We send them a new drive with their data on it, and they say, "When you sent back my original drive, it didn't have the USB cable it came with." Like, that's the level that we're held to. And fine, I'll give them a new one.
Exactly.
I'll give them a new one. I'll apologize. I'll mail it to them and everything. I'm asking you, when you gave thousands of dollars of money to somebody who was not supposed to get it, when it's in writing, when it's in effing call recordings, give me that shit back. Or if you can't, take accountability or responsibility for it. If you lose $1,800 of packages, don't hang up the phone. It's not even the fact that you screwed up, because I fuck up things on a regular basis, and you see it. Like, I literally live stream screwing things up on a regular basis. But what I do is I apologize, I attempt to correct it, I stay late, I'll work something out with the customer, I'll buy a new of whatever it is I screwed up, or there's accountability that we take when we screw something up for a customer that I would like to see businesses that have control over my money or my packages or other things take. And it doesn't seem to be universal there. It seems like, and this is just me being a whiny bitch at the moment, so we'll get to the board repair in a minute. It seems like everybody else is held to a standard that is not held to a standard that I'm expected to be held to. And after a while, it just pisses you off. Anyway, let's. But yeah, after that, I've already reported that postal worker, since they didn't get back to me, the USPIS has not gotten back to me. So I decided to report them to someplace else. Yeah, the post. Oh, what was it that I? It was. Yeah. Yeah, Postal Regulatory Commission. So I PRC.gov. So I also reported them to the Postal Regulatory Commission. If you're not going to get it back, that's fine, but you don't get to hang up the phone and just think that the problem's going to go away when you cost someone thousands of dollars. That's just not the way life works for me. It's not the way life has ever worked for me, and it's just not I'm just not going to let someone off the hook that easy. If that makes me an asshole, then so be it. But you just don't get to just get away with stuff like that. It's not happening. Anyway, so let us go over to this little MacBook over here and get started. Now that I have QQ'd all I have to QQ for the day, it's taking 5 volts at 30 milliamps, and it's stuck there. Now, on these machines, in order for the USB-C charger to be able to put out 20 volts rather than 5 volts, which it would typically put out for a phone, the computer needs to communicate with that charger. So it needs to say, hey, I'm a MacBook. 5 volts doesn't mean shit to me. I need 20 volts. And there's a chipset that's going to do that. So let's go over that on this machine. This looks like an 820-00239, one of our favorite little touch bars over here, back from when that's how life works if you're a government. Yep. But the payroll company is a private company. So, I mean, it's just idiocy in general. It's not government versus private in that sense. It's just idiocy. So let's find this system in this circuit. So this is our favorite little A1706 touch bar. This is back when they still had the Lifeboat connector that allows you to get your data. If the machine dies, good luck on one of the newer ones. So over here we have the charge port. This is going to be where the charger plugs in the machine. So this is the charging. This is the charging port, and that's the connector where it connects to the machine. Now, if we go over the schematic and board view, you'll see that there's all different types of signals in this charging port. And if you click on them, we have one over here that goes over to a chip. Look, I still love you, says Oreo. You don't clean your ass, Oreo. Piernov says, I thought the favorite over at Rossman Group is the 820-00045. You go to hell and you die, Frenchman. No. You replace CPUs on that. Have fun with that dual layer CPU, Piernov. Dare you wish those on other people. And so, back to this. You know, if we take a look, you'll see that it goes to this chip, U3100. U3100. This is the USB-C port controller. Now, you may be wrong, Stealthy Bong. Now, over here, we have voltage that goes into the chip, and as I've gone over many times, we need our voltage in for this USB-C chip to work and do its job. The voltage that it needs is PP3V3 underscore G3 hot. Let's take a look and see if PP3V3 underscore G3 hot is present on this machine. We're just going to turn on my multimeter, turn on Paul Daniels' awful software, and pray that it works today. And we have 0 volts on PP3V3 underscore G3 hot. So now what we have to do is try and figure out why there's 0 volts on PP3V3 underscore G3 hot. Could there be a short circuit to ground? Maybe. We're going to put the multimeter into ohms mode so we can check for a short. And let's see if that's the case. No short circuit to ground. Alright, so now we're going to have to do a little bit more investigating. We're going to have to find the circuit responsible for creating PP3V3 underscore G3 hot. Now this is the part that used to confuse many of my students in the past. When I would say a power rail is not being created, you have to go through my document and it says either A, it's not being, what chip responsible for creating it is not being enabled, so the enable pin on that doesn't have voltage going to it. B, there's a short to ground. C, the chip itself has died. Something along those lines. But the thing is, you need to know how to locate where that rail is being created in order to tell. Or, obviously, D. Shit, I forgot. All right, edit that out. All right, in the edited version. Or D, the input voltage that's going into that chip that's creating the power rail is not present. But in order to find this, you do need to know how to find out where that power rail is coming from. This is the part that would confuse many of my prior students. So if you have PP3V3 underscore G3 hot over here, many people would think that this is, look, I see PP3V3 underscore G3 hot, and there's a line going to this chip, which means it must be being created by this chip. Wrong. That is it going into this chip. We need to figure out where it's coming out of. Okay, it's looking for the wrong thing now. Let's see. How do we search in Paul Daniels' software? So slash doesn't seem to be doing it anymore. Control F, finally. PP3V3 underscore G3 hot. Research. Okay, that's it going into a chip. See this? Into a chip. Not because it's going into the VDD pin on the top. Next, this is it going into a chip. Next, into a chip, because typically the inputs are going to be on the top, and here it says V in over here, so that's obviously going into a chip. This is it going to a connector. This is it going into what I imagine is an SMC. This is it going into pull-up resistors. This is what you have going in, and this even says in, so if somebody were to tell me that this is where it's coming out of, that is the point at which you throw your goot wick at them. Over here, this is it going into a logic gate, going into a Hall effect sensor. Look, it is powering a Hall effect sensor. Now, somebody may say, well, look, it's on the right side, not the left, because many people would wonder, well, is it which side of the chip it's on that says whether it's output? Well, that's part of the story, but it's not the whole story, like any language. This is a Hall sensor, so we have ground, power, and this. Does a Hall sensor create power? No. Next. Nope, that's it going into a logic gate. That's it being used as a voltage for data lines on these two pull-up resistors. Nope. Nope. Okay, this is it going into a current sense resistor. So this is a current sense resistor that wants to see, it's going to measure the difference in voltage from here to here and try to tell how much power is being used by everything on this rail, but that's still not where this is being created. This is it going to a connector. And what do you know? This is here, PP3V3 underscore G3 hot, so let's follow. Okay. It's coming out of this chip. And it looks like battery voltage, PP bus G3 hot, and charger voltage, PPDCN underscore G3 hot, is going into this chip. So this chip has charger power going into it, PP3V3 coming out of it. Ding, ding, ding. I think we have a winner. This is the circuit that's creating PP3V3 underscore G3 hot. So let's go over this circuit and figure out what it is that's going on with it. So over here, we have a MAX 77596. Now, which one of these pins is going to be the pin that tells the chip to turn on? Because remember, we cannot blame the chip. We cannot blame the chip until we know if the chip is actually what is doing something wrong. I can't blame my light bulb if my switch is not turned on. So what would be the switch that tells this chip to turn on and get that power rail ready? Pin 10, EN. Excellent. Twitch chat is high IQ today. Twitch chat is beating YouTube by a considerable amount of time. Good job, Twitch chat. So, Twitch chat wins. Pin 10, enable. Power management, enable, P3V3 underscore G3 hot. So now, let's see if we're actually getting anything over there or not, because we may not be getting anything over there, and if we're not getting anything over there, we cannot blame the chip when it's not the problem. YouTube chat has evolved into Oreo's best kitten. Yep. The chat that is defending an idiot is the chat that can't figure it out. Wow. Imagine my surprise. Something that cannot wipe its own ass is not the best. Anyway, so let's go over this and find out what's going on. So obviously you gotta get a better picture going over here because this is blinding. Anyway, what do you have here? This probe looks a little strange, but we're not going to go off on that yet. So it looks like over here, pin 10 is going to be the enable. So let's take a look. I'm going to plug the charger in and see if this is being enabled. And you're going to be able to see along with me. 0.12 volts. Now, typically we're expecting on an enable, if it's an iPhone, like 1.7, because that's the voltage that most of the iPhone signals are sent with. On a MacBook, it's 3.3 volts, because most of the pull-up rails are run by 3.3 volts. Most of the pull-up lines, I should say this again. Most of the data lines and most of the pull-up resistors are pulled up by 3.3 volts. So most of the signals in the machine, if you take a look, you'll notice are pulled up by PP3v3 underscore G3 hot or PP3v3 S5. So I'm expecting the logic to be 3.3 volts on a MacBook, 1.7 to 1.8 volts on an iPhone. Either way, 0.12 volts, that's not doing it. So let's try and figure out where that comes from. Let's explore the schematic over here. Now, if we draw, you'll see there's a line drawing here because Paul Daniels' software is awesome and will show you everywhere in the board that signal shows up, unlike Landrex TestLink. And that comes from U7000. So let's take a look at U7000. U7000 is the battery charging chip, and this is an ISL 9239 P-bus supply and battery charger. And that signal, PMEN P3v3 underscore G3 hot, comes out of this chip. Now, the next thing we're going to do is take a look around that area and also see if certain things are present there. Do we have voltage at VDDA and VDDP? Is this chip turning on? Because this chip's got to turn on before it's going to output the signals that I need. So let's take everything out of this machine and take a look at that beautiful ISL 9239 and see what's going on around there. The Phantom of the Opera is there inside my mind. Dun dun. This. Here we have the ISO 9239. Now we're going to go over a couple of things that we were looking for. First, it looks like we're supposed to have power going into the chip, and we can see that on each side of R7075. Let's see what we get on each side of R7075 by measuring with the multimeter, using Paul Daniels' software, which you could find on pldaniels.com. Actually, I have the wrong board. This is not an 820000239. This is an 820000923. Okay. Do I have that one? Damn, I may have to grab that one. Give me 1 second, bro. Let me just Skype Tim Cook. I just gotta send a Skype message to Tim Cook and tell him I'm missing an 820000923. Here we go. Oh, what a fucking gracious guy he is. One second. Tim Cook is getting me the schematic as we speak. There we go. Everybody, a round of applause for Tim Cook for being available on Skype. It really did. It was something in that R Apple thread where they said Lewis admits that he used parts from a factory that may have made them for Apple, that now made them for him. Yep. It's almost like that's what I've been doing for like 10 years. They think I get my batteries from Tim Cook. Lol. Lollercopter. Okay. Lollercopter. Rafflecopter as well. So R7075 is still on the other side of the board. Nah, boo. I don't want to turn the board over because every time I do that the rubber pieces fall off the damn charger. Somewhere at Apple I know that there's got to be like 50 of these things just there. How many of these are on the floor of Apple authorized repair facilities because they come off so easily? They got rid of that in the 2018 model because I know that they must have like 80 pounds of those things a day at the higher volume facilities. Okay, so we're instructions unclear, typed asterisks. What does that mean, Copass? Alright, anyway, so let's turn on the multimeter software, measure, and confirm. This is a tricky one to get to. You're going to probably need some multimeter micro probes because normal probes are not going to reach here. Probes available on store.rossmangroup.com. 0.2 volts. 0.2. Alright, that seems kind of low. Now let's take a look over here at the schematic and board view. Where am I expecting this to come from? TBA VDDA and TBA VDDP. It seems like that voltage is actually created by U7000 itself. So U7000 is not... See, this is the thing. It's not that one signal coming out of it is missing. It's that many voltages that I would expect to be able to measure on it are missing. So if it was only one, then I would say, okay, if it's one missing, then maybe one of these other things it's supposed to be talking to, maybe the SMC is telling it to stay off, or which probably isn't happening here because it needs PP3V3 anyway. Like maybe one of these signals over here is not what it's supposed to be, and that's why I'm getting 0.2. But the fact that I'm getting 0.2 on the output that I'm expecting, as well as I'm getting it on VDDA and VDDP, means that most likely this is an issue localized to the ISL. It's 9239. This is where pattern recognition comes in handy. I'm noticing a pattern that where I'm supposed to be getting 3 or 5 or 2 or whatever volts, I'm getting 0.1 or 0.2 out of this chip. And since the same thing's happening in multiple locations, I am going to guess that it is the chip that is bad, and now I'm going to replace it. And if you want a schematic like the one that I'm using right here, because this is a comment that comes up constantly, now, we are going to remove this chip and replace it with a superior one from store.rossmangroup.com. Don't delay. Buy your chips from store.rossmangroup.com so Supervisor Joshua Pack at USPS can lose all of them and then take no accountability for it. I almost knocked that cap off, but I recovered. I caught myself. Thank you. I don't deserve that, Orhan. Orhan just gave me a bunch of magnets. I'm not pushing too hard on any of these, but I simply want to lift up all that old lead-free solder. I'm not going to wick those pads. I'm not a madman like Paul. Paul's an absolute madman. Like, there are some pads that I just will not wick, and Paul will wick those because he's crazy. All right, be right back.
A hook. I'm trying to hang a hook.
Where are all the hooks?
It's not a T8.
There's
Some in here, and some smaller ones.
You're a CD3.
They should be in the same compartment. But this box is like mostly for pictures. And then these are some like random ones that I have. Like I have some smaller ones. These are supposed to be for like Christmas lights. There's like literal oh. You got one of these? My old apartment only had the 2 prongs out. There's the other end of my curtain rod.
Nice.
You're a diode.
Welcome back. Thank you.
Welcome. See y'all. Bye.
Do you know where ISO 9239 is?
We got another
I thought I remembered the slot this was in.
No one's looked at it yet. No
What?
one's looked at it yet.
Oh, so the 2.
She, I told her what it could be,
3 is SSDs dead.
and
Don't fix it.
I'm pretty sure
You like making people cry, Hannah, so.
she, no, she said, I really want to fix it because it's the last
No, these are getting fucked up.
Okay. I got myself a chip. Yeah, I put squelch on my microphone, but it's still not squelching it when the signal's far away. I don't know why the receiver is doing that. And we no longer have a stream assistant, so stream assistant went back to college. It's a lovely mic. It's not a bad mic. It's a DPA microphone, and it's a Sennheiser SK100 transmitter and an EK100 receiver. It's just that the Sennheiser receiver, for some reason, mine, when you put squelch on, it stops squelching. So the squelch feature used to work. I don't know what the hell happened to it, and I just haven't had the time or the inclination to research it. See, this is the kind of stuff I'd be jealous of Linus for, because I've got all sorts of people going, you're jealous of his views, man. Like, I don't give a fuck about any of that. What I am jealous of is that fucker told me I've never had to record my own YouTube videos, or any of my own videos. Somebody else sets up all the equipment for me. It's like, you motherfucker. I want somebody to figure out squelch. I want to be able to just tell somebody, figure out why squelch doesn't work on this microphone. Okay, go. I've tried squelch, I've tried pilot tone. I'm not trusting someone who can't spell receiver. Okay. This is the ISL 9239 here. And this is going to be a new one that we put on there. I may actually just wind up wicking the pads after all. I forgot how annoying it is to solder a chip when there's balls under it that are... to solder a chip when the pads are not flat. Yeah, I forgot how annoying this is. Soldering a BGA. Okay, come on. So they're going to fly off the board or fly into place? One or the other. Wow, it flew into place. That was some magic right there. Okay, get it to dance a little bit. That's rude, bro. Oh well. I don't know. There's something about useless troubleshooting that drives me nuts. What do you mean read? It's analog. Like, it's analog. I will cop to being a rude asshole. I'll own it. I'll own it. Okay. So we're going to give this thing over to the good old Rapid Cool technology. Enjoy the vegan chocolate bites. Oh, wow. Thank you. JP, you're too kind. I haven't done anything worth all of this. Okay. And if you rewind to the beginning of the stream, you'll see why I'm salty today. Extra salty. Super salty. Who earns more money, you or Linus? I would guess Linus. You never know, because I mean, on YouTube, like, he sure as hell kicks my ass. In business, I don't know. Probably him, but still, you never know. Can't really know when it comes to public versus private companies. Okay, so we have Rapid Cool technology, the board. Now let's see what happens when we plug it in. Little rubber piece tried to escape.
Yeah, a kind person sent you this. Becky Bites.
Whoa! Oh, JP sent this.
Oh, JP?
Yeah. This is the guy that sent the Nerf stuff.
Who?
The Nerf guns. Thank you. I will try one. Steve, would you like one?
I tried one already.
You stole my chocolate?
Well, no, what I'm doing is delivery men are delivering food to the wrong place. I'm just eating it. I can't deal with the inconvenience.
My pinky doesn't have any flux on it. It's cold on the inside. Who gives a shit if that board works? You have to try one of these. This is amazing.
Oh, we did already. We already did.
What? You tried all my... You fuck faces? I thanked you for the magnet. Yeah, he's the only one who deserves it. He gave me a magnet.
Everybody, try.
He tried one already.
Oh, no.
You have one on your desk. What are you lying?
No. I have now.
I already had one, but I won't say no.
So anything I get gets filtered through 12 people before I get
Yeah,
it.
exactly, because you're last. So it literally was passed down. Like,
It wasn't poison.
actually, yeah, that way you'll never get poisoned.
Oh,
You're
if
the
it
last
was
one.
Kevin, then I believe it. Kevin's the official poison tester. Olga, I'm sure you've already tried one, but... You already tried it, didn't you? Yeah, check.
Thank you. The beer still warm. I took for the beer.
I'll assume Hannah's had 3 already.
I had one, but I also had peanut butter. Thank you, Louis.
That was really good.
You asshole.
What? It got filtered, you know? You're the last one in the store at the end next to the bathroom. So.
Should not be eating these.
They're vegan.
I'm a fat ass. I can't afford this. Oh, so this motherboard. Yeah, we should probably see if this thing actually works. Alright, do we get 20 volts or 5 volts? Plug it in. $20 volts, but that took a little too long. And we're taking 20 milliamps. That took way too long. It should switch on in like 1, 2, bam. Not 7 seconds or so. So let's see if our PP bus is present. Also, I hope that my ISL is well soldered. Alright. So we get 0.74 volts on PP bus. So I'm going to go with I perhaps overheated that chip or soldered it improperly because I'm an idiot. But since I don't work for my shitty payroll company or the postal service, I'm actually going to fix the mistake that I made. Let's try doing this one more time. That wasn't real communism. It's not a real ISL 9239. Just one more try. I don't feel like that was my best soldering. Let's solder a new one onto the board using my soldering iron. I thought you were trying to take my chocolate. Micro pencil is not for wicking. Okay, time to gesso the pads. You're sleeping. My iron fell asleep. I was wondering why so powerless. Trying to have it go over individual sections. The pads have almost been entirely gessoed. I used to teach with Jessa Jones over at Practical Board Repair School, and when I worked with her, one of the secrets that she taught me to her vibrant success was that she wicked the pads under every single chip that she ever replaced. And I've been carrying that with me for the past 4 years. And it's allowed me to be successful just like Jessa Jones. Some particular elements of this board look nasty to me. Oh, Erica, you fell for it. Erica, ban that person when they finish that sentence. Okay, we're gonna grab another ISL 9239 and solder it on. I'm gonna walk out front. Let me just turn on squelch one more time. I'm pretty sure that squelch is not gonna work, because it hasn't been for a while. Huh. Okay, let's see if I take pilot tone inactive on here rather than active. And squelch middle. Let's see what this does. Yeah, this is really shitty. Squelch feature on this transmitter, this receiver, doesn't work anymore. There's not much I can do about it. So every time I walk up to the front, you guys are just gonna have to turn your volume off until I find a new stream assistant to figure this shit out, because I do not have time for it.
Long time outside now. I'm doing that.
You can click this 1, 2, and then. Let me see if I have this camera for me to even try a new one on there for you. Give me a second, okay? Let me see if I have this. Yeah, can you actually see if you have it? That's the 6S Plus.
I'll be a good Copaz. Please make it stop. Yeah, I wish. I don't know what I did to screw this up. if it's not straightforward, it's going to be something that requires in-depth research and time that could be better spent fixing MacBooks or doing all the other stuff. Since HAKKO is back in school, perhaps we should find a new... The thing is, I don't even know if I can replace HAKKO's position, because HAKKO didn't even have a desk. He would usually be sitting by the garbage pail editing video. I mean, he was as close to homeless as you get working here. No, Ping Sina is too far away to be an assistant, I'm afraid. It's a local position. You can't telecommute. Okay, it dropped into place. Instead of sending Erica plane tickets in a cat carrier, how about I use the cat carrier I have and get him a plane ticket to Erica? Oreo wants to visit her. You can work alongside Oreo. I'll send Oreo to you. Do you miss Oreo? JP also said he would donate to that cause, so let's make it happen. Let's get Oreo sent over. We can live stream Oreo shitting, shitting in a passenger seat of the plane. Okay. Let's see what we have here. Any difference? Okay, plug in the charger. 1, 2, 3. You're not switched over to 20 volts in time. Yeah, you're taking 5 or 6 seconds to switch over to 20 volts. Let's see. I'll take a look at SMC in just a moment. So, here's a couple of things I'm going to want to go over here. The first is going to be, let's see if we have any change, remember, on VDDA and VDDP around the ISL 6259. Oreo would love to meet the lovebird. Oreo and Salsa would make such good friends. As long as Salsa was a grass-fed Salsa, I'm sure that Erica would be okay with it. It's a grass-fed Salsa, it's just fine. Okay, so we check each side here. 5 volts. 5 volts. Okay, we've made some progress there. So we are... Oh, you couldn't see that. So we replaced the ISL 9239. 5 volts here. 5 volts here. So that is a good grass-fed ISL 9239 over there. As you can see, these two lines that were missing before are not missing now, and that's a good thing. But the next step is going to be figuring out why it is stuck with PP bus G3 hot. Let's see, at this low voltage. So we've got 0.7 volts on PP bus G3 hot. Now, the next thing we're going to do is we're going to see one of the other reasons why. Maybe this is short to ground on PP bus G3 hot. You never know. So PP bus G3 hot, the rail that this chip is going to be responsible for creating over here, we can find out an F7000. F7000 is this fuse that you see over here. You're going to unplug the power from the charger because that's going to mess up our readings. 500 kiloohms to ground. And let's see, the fuse is good, and we have 500 kiloohms to ground. So this is going to be difficult. This is not going to be a fun one. So we have to figure out why PP bus G3 hot is low, and also why is that ISL delayed and it's turning on. So let's go over to the ISL 9239 and go over this as if it was an ISL 6259. Now, in order for everything here to work properly, current sensing has got to be in order. So let's see. So we've got CSIN, CSIP. So charger current sensing, we have a 1 ohm resistor here, a 1 ohm resistor there, and that's going through a 0.01 ohm resistor. So if I measure on C7023 over here, I should get 2.0 something ohms. So let's take a look at C7023. Let's just make sure that our current sensing resistors are okay. I haven't had current sensing problems a lot on this model machine, so I'm not used to them occurring, so I don't look for them when I should. So let's see, C7023 is going to be over here. So we're going to measure the resistance. And we get 2 point something ohms, which is what I was expecting, so that's not going to be the issue. Now there's also current sensing for the battery usually, and let's see if we have that on this machine as well. So we have this current sense resistor, R7060. And then the C7020 is going to be for battery current sensing. And that's going to be under the ISL right over here. 2.8. So that's doing what it's supposed to. So now let's just go through troubleshooting this the way we used to. So P-in. We have P-in on our schematic. P-in. Power in. Is that something we can measure, or is that going to be under a ball? That is going to be under a ball. So that's going to be... yeah, good luck measuring that. Charger's cell is what's going to set PP bus G3 hot. But that seems like it has an internal connection to this, which we already know is present from having measured on the other side of the board. If it's not pulling up charger cell, PP bus is going to be a strange number. C7075 is 5 volts. Let's see what charging volts is coming into the machine out of curiosity. Let's check C7023. $20 volts is coming in to the machine. Okay, so we have this aux detect funniness in the schematic over here. What is aux detect? Thunderbolt auxiliary detect. It's probably fine. R7015, R7016. This looks like similar to charger AC in on the older machines. That's what I would expect. PPVin G3 hot, P3V3 G3 hot. Okay, what's that? Oh, that also goes to a diode over here for PP3V3 underscore G3 hot input. Let's see what that is. That should be 20 volts coming from the charger as well. So what do we get for you? $19.8. That's good. EP3v3 underscore G3 hot is supposed to go to R7009 for high power enable. Well, let's see if that's present or missing. R7009. On one side is PP3v3 underscore G3 hot. On the other, it's pulled up. So high power enable is present. Let's see. SMC 4-finger reset. This is about to get a 4-finger reset if I have something to say about it. I'm gonna fucking push you down a flight of stairs. I'm gonna fucking wreck your shit. As Chris Cuomo would say. What do we got? SMC 4-finger reset is low. .1 volts. That's strange because I'd be expecting 0 volts or 3 or 5. Nice. Let's see what we have here. So if SMC on-off L is present, SMC LSOC reset L, then you get SMC finger reset. Okay, so that's supposed to be reset when low, and that's power button low. So I'm not pressing the power button, and I'm not resetting this. So why is this not shooting out SMC 4-finger reset? Huh. Let's take a look here. Is my SMC stuck in reset mode for some reason? See, I'm no Fredo. Do I look like a Fredo? Can't fix a board? I'll fucking wreck your shit. Okay, so let's see what we get on pin 1 and pin 2. Pin 1, 0. Pin 2. This can't be right. If SMC on-off L is low, that means it thinks the power button is being held down. Okay, now SMC LSOC reset is high. Actually, no, SMC, no, that's LSO. Okay, restart. SMC LSOC is 3.4. SMC on-off L is 3.4. 4-finger reset is 0. Now what I need to do is get the truth table for this logic gate. How does this logic gate work? Am I supposed to be getting SMC 4-finger reset? Or not supposed to be getting SMC 4-finger reset? Because I'm getting 0 on out when those two are in, and that's not usually how most of the logic gates in this machine work. So let's get a truth table for this. So I'm going to try copying and pasting this and Googling it if Paul Daniels' software will allow it. Paul Daniels' software is typically not friendly to the concept of copy and paste. So let's go over this. This looks like a really basic NOR gate. And we're going to find the truth table for this NOR gate. We're going to find the truth. Or I'll fucking wreck your shit. I'm Chris Cuomo. So this is a NOR gate, so if either input is high, the output will be low. So that is doing its job. So that chip is so SMC 4-finger reset is supposed to be low, which means that that is a red herring entirely unrelated to why our PP bus is missing. Okay, so we're going to go back to finding the truth. Donald Hanson can't handle the truth. Let's see if the SMC is having a conversation with this machine. So we have an SMC data line that's supposed to be over here. Is the SMC having a conversation with my machine? SMC data line stuck at 0.7 volts. Aha. Aha. Alright, so the now notice this chip has communication line with the SMC. 0.7 is not valid. You're not a data line that's pulled up by 0.7 volts. So take a look over here. We have an SDA and an SCL line. That means there's an SM bus line. That means that this is having a conversation. So this is having something is having a conversation with this chip. SM bus SMC 5 G3 SDA. Now where does that conversation go? So we've got a diode here. That's going to be talking to the battery. And it's going to be talking to the power management chip. And it's going to be talking to the SMC. Now that's probably going to be pulled up by a set of resistors, and bam, right over here, it's pulled up by R5380. R5380 is, this is going to be pulling it up to 3.3 volts. So this is a data line, and you can go over my sheet where I go over what a data line is. It's going to be a guide, a border pair starting guide below, where it explains things like what is a pull-up resistor, what is a data line, and so on and so forth, for those of you who are new. But this is a 3.3 volt data line that and this is pulled up by R5380. Now anytime one of these chips wants to talk to one another, anytime the battery charger, or the banjo, the PMIC, want to speak, what they do is they pull that 3.3 line down to ground. So think of this like, what's that little thing that you would go like, the telegraph machine?
Morse code.
Morse code, yeah, that kind of shit. So imagine that you have a constant 3 volts on the line, and every time you type in your little Morse code thing, it's lowering it to 0. So imagine it like that. So if you want to do SOS, you're like deet 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 deet. Now, in order for you to pull the line down when you press a little button, it has to be pulled up by something, and that's kind of what's going on over here. So what you have going on over here is that this is a resistor that's sitting between a 3.3 volt power line. No, this is a resistor that sits between a 3.3 volt power line and this data line. And then you have the SMC, the battery charger, the PMIC, and the battery there. And anytime one of these chips wants to talk, it's going to go deep, 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 deep. Now, the thing is that I should see 3.40, 3.40, 3.40. It should be doing something like this. And I don't write books because the 150-page guide that's in the links down below, most people don't even read as is, so that would probably never get read by anybody. So it's going to be doing this. Now, if you're stuck, if this is a pull-up 3.4, and it's supposed to go down to 0 when it's talking, and you're stuck over here, like just a flat line here, that means one of those chips is short at the ground and probably pulling something down. Now, we know it's not the ISL 9239 that's doing it because we've replaced it already. Also, by the way, check this out. This is funny. So see how it says ISL 6259? Apple had not used a 6259 for 3 years since the schematic was made, but they're still typing ISL 6259 into the schematic. But independent repair people are the ones that can't be trusted. you can't even write down the accurate nomenclature and names and model numbers of the devices you use in your computer in the schematics and diagrams that you're drawing. I would like to make the case that if somebody shares this document, that they're not even sharing intellectual property, because how much intellect went into writing this? But anyway, back to, let's not get too salty now. So we're going to have to see if any one of these things looks corroded around the area. But before I even do that, let's take a look at R5380 and let's make sure that it hasn't failed. So R5380, let's see where that is. Okay, we have a little, looks like maybe some, I don't know what this is. Is this a pube? Is this some potato salad? Is that weed? Who knows? Right, let's find this pull-up resistor. So this pull-up resistor is located in a bank right over here. So it's going to be, according to the schematic, 1, 2, 3, 4. So the fourth one over. Alright, so I'm going to unplug the charger. Unplug the charger and measure that resistor. Just make sure that it's the 2 kiloohms that it's supposed to be. Or close to that. Doesn't have to be exact, but just should be not too far off. Yep, that resistor's fine. It's resisting. Alright, so now we have to look at the things that are attached to it. The first thing I'm going to do is take a look at where the battery management system would plug into the computer. Now, over here, also I'm kind of curious to see what the resistance is to ground. The schematic was written by our lizards at lizardbrain.com. Lizardbrain.com, you can find A1534s with completely dead CPUs. Don't delay, buy today. Indeed, Copass. Indeed. So, if you look here, it doesn't look like we're shorted to ground. It looks like whatever's keeping it stuck to ground is probably a component along the line. So, let's take a look around the other things that are attached here. So, it's not U7000, it's not that. So, let's see, we've already checked. We've taken a look at the U7000 and replaced it. It's not U. We've taken a look at the resistor. That resistor's fine. Next up, it goes to a diode over here. Now, there are several things that could be potentially shorting it to ground. Either behind door number 1, this teeny tiny little diode is bad. Behind door number 2, our SMC with a bunch of little balls is bad. Behind door number 3, U7800, the PMIC is bad. Now, the one of the ways that I can try and figure out which of those chips is most likely is, one of the ways I can do that is using the thermal camera. But since we're taking 20 milliamps at 20 volts, that means that we are taking... We're taking we're taking virtually no power at all there. We're taking like 0.4 watts. I don't think anything's going to get hot. So I don't even think the thermal camera would be able to give me an idea of what's wrong. So let's just do a eyeball inspection. So this is the SMC. This is the PMIC. This is the diode. So we're down to the wire here in terms of our hints. This is going to be virtually anything holding that data line down at this point. And since Anel gave me this board, you're going to get to see him reball a PMIC and an SMC live on camera, if that's what this winds up being.
Don't torture Anel. He's a good sport.
Anel gave me this board.
Oh, he gave you that board. Oh, yeah.
Anel handed this to me and said, I think I have an easy one for video.
What? Why would you set him up like that?
Thanks to you, I fixed my PS4 Slim today. Thank you, says Notlers. Wow. Thank you very much for the kind words, and I'm glad you fixed your PS4. If you need any tips on PS4 repair, please email steve@rossmangroup.com.
Tell him, does he mod PS1? Remember installing the mod chip?
That was fun. Okay. So, I'm going to hope and pray that one of these components is taking 0.4 watts, and that one of them gets hot into the thermal camera. That's probably not going to happen. But Steve! The moment you closed the bathroom door, the electricity went out. You bastard! Your shit ruined the store.
Deal breaker.
I don't even have my bike plugged in. What was that? Well, I guess the UPS did its job. I'm fairly happy with this UPS doing its job. The stream is still up? Is the stream still going? Everybody still there? Alright. Alright, I need to borrow the thermal camera, so BRB. Wait, so seriously, the printer has the power to destroy the electricity?
There's probably no filter on it, and it's probably AC.
I mean, of all the things to blow it, the printer.
Did you not see when the printer turns on, the lights over there dim?
Yeah. That's pathetic.
Not dim, but maybe like AC shake.
Wow. The store is a shithole. Alright, so I'm walking up front, so mute your headphones. Because as soon as I walk up here, you'll hear a burst of static. Ah. I'll bring this right back. The print, every time you use the printer, it destroys the electricity.
Wait, were you connected to the APC?
Yeah, it was. It doesn't say how much. I'm curious what this is using when I'm streaming with the GPU and encoding with the CPU. So that's stressing it hardcore.
Look at the light flicker. Ooh. Wait, so then your stream didn't drop?
Nope, still up. Okay. Now, how do you power the thermal Pepe? Here we go. This is the power for the thermal Pepe. And Ethernet for the thermal Pepe. Okay, so now we are going to turn on the thermal Pepe software. Do you ever use your TS100? No, I can't even find those, honestly. I think I sent the TS80 to Nacera, which the Post-Nord lost because Post-Nord. TS100, I need to use that to fix my bike at home, actually, because my other bike isn't working properly. I gotta solder in my hall sensor wires. Okay, so let's take a look at this on screen. And as you can see, the moment you turn it on, the system management controller chip starts to get hot. So the SMC is... Yeah, so the PMIC is 24 Celsius, the board is 24 Celsius, and the SMC at its hottest point... Yeah, the SMC is 5 Celsius above everything else. So the SMC is going to be what's at fault here, and the diode is not even getting remotely warm. So at this point, I'm going to hand the stream over to our assistant Anel, who is going to reball the SMC. All right, then. Do you have a stencil?
Yeah, we just got them.
Oh, boy. Joy. All right.
Find out
Yeah, I may or may not have spilled Windex on that Lenovo keyboard. It's one of the reasons that my keyboards last for about a week or two. I went full Mac user on it.
Okay, I got my stencil. We're gonna find out what board this is. What board? 26, right? Yeah, they're underfilled, so it's a sensitive 6 machine. There's the board number 092. Oh wait, I have the mic right here. Cool. Let's put that on. Okay, so we're gonna do an SMC replacement. I need this thing. There we go. Cool. So we're gonna remove the old one. You know, out with the old, in with the new. Get a microscope cam. That's our guy. Get some flux on there. Grab my special tweezers. Don't know where they are. Aha! Okay. Now we're gonna wick those pads. Grab my iron. Okay, looking good. I'm just gonna clean that area off. Perfect. So I should find out where we got this SMC stencil, and we should probably sell it to you guys. But, oh, and I dropped it. It's gone forever. Uh-oh. Found it. Awesome. Yeah, I should ask Lewis if we can get more of these stencils. It's almost like a universal stencil. Has one pin missing. This is good for PMICs and SMCs. They're like legit the same size. Perfect. So what I'm gonna do now is I'm gonna put this board away for now. We're gonna grab our donor, grab that SMC. Some flux on there. And we're gonna remove it. Just watch the donor's dead. No, this board actually turns on, but is brain dead. This donor board. This is my secret board that no one knows about. So everything about this board works except for the CPU. And now SMC. So now that we have our donor SMC, I'm gonna leave that right there for now. Put this away. And now I don't know if I could show this on cam. We have this SMC holder. We can open it up and close it. We're gonna just place that new SMC right on here. Like so. Then we're gonna wick all the nasty I should get a new, my wick's a little disgusting looking. Let's cut that off. Chomp. Okay. So we can use that wick that we get at store.rawsongroup.com and watch these pads come clean off. Look at that. Nice, beautiful looking SMC. Oh, I didn't make this tight enough. I'll fix that in a sec. Cool. So now we're gonna make sure this is firmly planted on here. Make it nice and tight so now it's not gonna move whenever we touch it. Alright, let's hit it one more time. I see a pad that hasn't been cleaned off. This corner. Okay. So now we just grab a Q-tip, clean off all that flux residue. Alright, looks clean enough. Now what we're gonna do is grab some Captain tape. And where did my oh, there it is. Okay, cool. Don't want to lose my stencil. Alright, where was I? Oh, there's some crud in here. Hold up, let me clean that off. Probably some dust from when it dropped on the ground. Okay. So now we're gonna align everything. Oops, wrong way. There we go. As you can see, every dot has a ball on it, except for the top right. So now we're going to grab a strip of tape. Just going to hold it down to the SMC. Like so. Try to realign it as we're taping it to make sure it's perfect. We don't sell Captain tape, but Captain tape is easy to find online. Maybe I should ask Lewis if we should sell it. There's really that much of a demand. Cool. So just try pushing it around to realign it so it looks nice. I want to tape all corners. I don't want this stencil to move in the slightest whenever I'm heating it. So yeah, the reason why I'm using Captain tape is because using any other tape, whenever it gets 500 degrees blown at it, other tapes would melt or start folding on itself, burning. Captain tape doesn't do that. It has a high heat resistance. And that's ideal when you're reballing and you don't want your stencil to move. This is being held in place. So now what I'm going to do is I'm going to grab some solder paste. Oh, I'm almost out of solder paste. Yeah, my tube's completely empty. One sec. Okay. Now I'm just going to put the solder paste on the board. I mean, the SMC. There we go. Nice little stick of gum. Now we're just going to spread it around this chip. I want all my balls to be filled with this paste. So I'm just going to run by it a couple times. Make sure every single ball has been given the same amount of love. Okay, now I feel like every ball has been covered. We're gonna Q-tip all the excess off. So when we heat it, all the balls don't just roll around and all this paste just becomes one giant clump. Hello? Test. Test. Okay, sorry, I dropped the thing. Hopefully your ears aren't dead. Okay, cool. I dropped the mic, basically. Anyway. So with the Q-tip, take off all that excess solder paste. Get all this stuff on the edge is gone too. I don't want it rolling around. Oh, awesome. How'd it go?
It was fine the whole time.
It never broke?
It did not break.
Then what did you do to it?
You were right. Wait, are you recording something?
Yes, I'm streaming.
Cool.
There we go. Alright, so now we're going to heat it. I want it to be fast as possible, just not to kill my SMC with the amount of heat I'm using. So I'm going to wait for my gun to go to 500, and then we're going to slowly approach the board, and you're going to see all the balls just melt. Okay, it's starting, the flux is melting. After the flux melts, here come the balls. One by one, they will all fall into place. Now we get this corner, and boom, all balls are melted. Take off the heat, and then you can peel off your SMC stencil. Hopefully it comes off in one piece. Ugh. Let's see. Nope. Alright, sometimes if you're not fast enough with removing the heat, the flux will solidify and your stencil and SMC will stick to each other. That's okay. All you have to do is place it back on the holder, hold it tight, and then you apply just a little amount of heat. You don't want to melt the solder. Enough just to melt the flux, and then you can, crap. Wasn't held properly. Get back in there, mofo. Alright. Cool. Just gonna heat it up again. And boom, done. There we go, have an SMC ready to be placed. Now you can look at all the balls again. You see that they're all on there, nice and beautiful. So now we're gonna delicately remove this from its bed. We're gonna get rid of this stencil holder. We're gonna go back to our board. And keep this in a safe spot. I don't want to lose it. We only have one. I gotta get Lewis to get more. Precious. And this is trash. This is my empty bottle of Amtech solder paste. Look how many SMCs I've reballed since I started working here. Gone. Alright, back at the microscope. Now I don't need to know what orientation my SMC needs to be on, because then I can see the hole there and I can just match the hole with the hole. Well, you probably can't see it. Alright. So it's going to be on the bottom right, that little hole. I'm just going to add a very little amount of flux. You don't want to put too much flux on here, because once you put that SMC on, once you start heating it, the flux is going to melt and your SMC might just flow out of place. It's going to start swimming. That's something you don't want to do. So you put a little amount, you grab some tweezers or some flat object, and you just rub it. You just gently massage your flux around every single pad on here, and that is ideal for an SMC. And that's probably why Lewis can't place SMCs on here. Okay, so now I'm going to place this newly balled SMC right on the board. And my tweezers have flux, so it's going to stick on, of course. Boom. Give it a little wiggle so it sticks onto the board. And we're ready for heating. Alright. Cross your fingers, boys. So we're just going to slowly melt the flux first, and then we're going to go in with the heat. So the flux is starting to melt. I'm going to inch closer and closer towards the SMC. Alright, now the flux is going to start bubbling. Oh no, it flowed into place. That's perfect. Alright, SMC just flew into place. I'm going to heat it up a little more and I'm going to give it a little nudge. Okay, all the balls are melted. You saw it move. That scared me. I thought it was flying away. It was actually just melting into place. Perfect. Alright, we're going to let this cool off for a bit, and then we're going to plug it in, see if we have a working board. So we're going to go to Lewis's patented rapid cooling technology. That scared me. Boop. Nice cooling fan. Alright, who's ready to see if this turns on? Board's still warm. I'll give it another minute. I'll re-chat. How you guys been? I'm sorry for neglecting you guys. I haven't streamed in so long. Also, I have school in 2 hours. Yikes. Alright. Next drunk stream, I'm banned from drinking and fixing boards. Alright, so now we're gonna try this. And boop. Got 5 volts. And we have 5 volts. Still 5 volts. 20 volts. Alright, maybe it wasn't the SMC after all. We're still getting the same response. Let's check the thermal cam and see. Where is it? Where did he put it? Oh well. Never mind, screw that. Let's check that data line that he was talking about, which is right here. Yeah. Second resistor from the top. Thermal Pepe is nowhere to be seen. Unfortunate. Alright, SMC data line. Still bad. Nothing's changed. There's still 146 millivolts, and the other one is 1.5. Nothing's changed.
Somebody called and they said, "Oh my God, I just got Lewis." I literally threw the phone at Steve and put it on speaker. That's so fucking creepy.
Did you change the ISL?
Yeah.
You did?
Wait, so do you have any change in the 0.7 volts in the data line?
I have 1.4 now. But the other one's 100 millivolts.
Is there anything getting warm still?
I don't have thermal Pepe.
So either it's the PMIC as well. No, okay, first knock the diode off by the battery management connector. Yeah, knock the diode off by the battery management connector. B, see if anything's getting warm. C, if that's the case, then we replace the PMIC as well. D, if that doesn't work, then you put a bad SMC on. E, give it to Paul.
I choose
So,
E.
No, that's not choices. That's an order of operations.
Darn. Okay. Well, first off, I'm gonna check this, because I'm pretty sure Lewis hasn't. And that might be dire to the situation. Let's see. These resistors should both be 2K. And if they're not, then oh well. Boop. We have 2K. Okay, another one. Also 2K. Perfect, alright. My doubts are gone. Let's just get rid of this diode. See what we get.
What does thermal Pepe say?
I don't have thermal Pepe. I don't know where he's at.
I'll give you thermal Pepe. Scrambling?
Yeah.
How bad?
I reballed SMC.
Did it work?
No. You walking off. Oh, wait a minute. I got a donation. I don't have sound. That's... where is it? Oh, shoot. Abdul? Well, we gotta... Oh, hold on. I gotta find Lewis. I gotta find something. I'll be right back. Someone donated 100.
$100?
Yes.
Now we have to fix
And now I don't know where to check it.
Check what?
The donation.
Oh, you missed it?
I missed it.
Was it
Chat's yelling at me.
Oh, you don't pay attention? Let's see, was it through Streamlabs or this?
It's from Abdul. You know that guy.
Abdulaziz, oh, that's the guy who left a comment me yesterday. 4-year school, good luck. Were you talking about school?
Yeah, I said I start in like an hour.
Okay, I'll use some money. Say thank you.
Thank you, Abdul. I'll use it to get food as a starving college student. Thank you, thank you. Sorry, I'm just really thrown off. I gotta start paying more attention. Get the thermal, Pepe working. Okay, so if anyone cares or is wondering, this is my last semester in my bachelor's program to be an electrical engineer. I'm finally almost done with school. Let's see if my SMC still gets hot. So we're gonna plug you in. Thermal Pepe angry. So once it kicks into 20 volts, something happens. So I'm just waiting. Okay, 20 volts. Oh wait, you guys can't see. How do I screen capture? Grab. Display cam? Ah, cool. Almost right. I don't matter. No. Yeah, okay, display cam. Okay, so SMC is no longer getting hot. So that's cool, right? That means my problem lies somewhere else. Is my PP bus still 4 volts? Let's find out. Check the fuse. 0.7. Yeah. That's no fun. Do I trust Lewis reballing? I mean, replacing the ISL? Let's look it over. So if our SMC is no longer getting hot, I believe it's good. Now something else is the issue. Maybe the SMC killed the ISL, and that's why we don't have PP bus. Let's see, microscope, sorry. No, that looks fine. What am I missing? Something ain't right. Oh well. I think Paul could figure this one out. Because you need... If I remove that... I can't remove it. Darn. Something isn't right, and it's really hard to check with this one because you can't just remove one thing and check the other. Because say if we had an error, and if we had those SDA and SCL signals low, I could remove the SMC and see if it's causing that issue. I can't do it here because I won't get 20 volts and I won't get 3v3 voltage without it because I need the SMC to be there, which is dumb. And I can't remove this chip to find out what's wrong with PP bus because this enables PP bus, and it's just a clusterfuck, honestly. Just buy a new MacBook. Absolutely, that's what I'm... I want to replace this. Does it? It looks a little cracked, honestly. Lewis, fuck it up. You guys see that? Little crack in the glass chip. I don't know if that's important or anything. Oh, this is going to Paul. He's gonna enjoy this one. Screw it. Rage quit. This is taking like 2 hours of our time. Earthquake. Sorry, this microscope doesn't really work well. Seasick? Sorry about that. Go through my rails. I don't have PP bus. Actually, let's see. 1 sec. I feel like you have a bad ISL. Not only is it cracked, but...
Replace.
Okay.
I replaced that one, so I probably did something stupid.
Alright. What slot is it in?
X5, X4, X3, X8, X7.
Okay, in the X's.
X5. Put the right chip.
Oh, you have a mic?
Yeah, I'm
Oh,
streaming.
are you streaming?
Yeah. You want to say something? Boneless?
No, I'm not here. Actually, yeah. Give me... Boneless. What's up?
You heard it here, folks. Kevin is boneless. Boneless.
Is there a vertical option?
What are you guys singing? Alright, if this doesn't solve it, then I'm calling it quits and going to Paul. Boneless pizza. Replace the whole board. Let's get this junk that Lewis touches. Everything he touches breaks. Okay, grab our wick. Make sure Jessa isn't watching this. Cool. Okay, pads are wicked. Let's get a Q-tip, clean off stuff. You know the drill. Nice clean pads. Dry it off. Add some flux. New ISL. Nice clean bald ISL available at store.rossengroup.com. Pin 1 on the bottom left, right, my bad. Okay. Gonna knock you into place. Boop. Alright, let's see. Replacing it for the third time. Well, Lewis replaced it. You know you can't trust him. Also, I have a feeling like the SMC just killed this ISL. Or something stupid happened. So it's gonna get nice and hot. It flowed into place. You all saw it move. Give it 2 more seconds of heat. 1, 2, and done. Let all that dry off. And let's see. They come already balled from your store. Yes, they do. Pre-ball chips at store.rossengroup.com. ISL 9239. Don't delay. Buy today. Rapid cool. Some fast seconds. It happened as I was talking, so it probably was more than 2 seconds. Let's cross our fingers, hope this works, otherwise I don't get to eat. According to Lewis, he won't let me leave. See, I don't have... Alright, right there. Cool. Plug you in. And we are still not changing fast enough. So there is something wrong with our everything. Still 0.04. Still no pee-pee bus. It's even worse now. And our signals are 0.02 and non-existent. Well, back to Paul. Unless, let's see what Thermal Pepe has to say one more time. What's it looking like? Is it a bad CD3215? Did that just get hot all of a sudden? Or am I just bugging out? No, I'm just bugging out. This board is trash. Goes back in the dumpster where it belongs. Check the other ports. How about that? Shut up, Kevin. Nope. Yeah, alright. Board's junk. Screw it. We're going somewhere else. That board's trash. Everyone knows it was. Screw the diode. The diode's not doing anything. Can't be the diode. Wait, 1.5. There's no way it's the diode. Fine. You guys are like screaming diode. Fine, you win. We'll get rid of the diode. That makes you happy. Oh, wait a minute. You guys are onto something. What's that? You guys can't see. Microscope. Say internal bolt shorts belong where it belongs, a dumpster in China. Oh, that's because it's... There we go. It's not the diode. Don't look at it. Fucking diode. Swear to God. Piece of shit diode. I can't use hot air, so this is coming off with an iron. Just gonna add enough solder to engrave it and then peel it right off. There we go. Chat wins. Alright. You got me. Oh crap. Oh, pins are moved. Ah. Okay. Get my donor. Alright, I gotta be quick with this, otherwise I'll burn the battery connector. Cool, it's on. And I slightly burned it, but it's not the worst thing. New diode on the board. Are you guys happy? How much you bet this does not solve the issue? Let's find out. You know what? Might solve the issue. No one talk. Alright? The diode was burned.
Huh?
The diode was burned.
It was a diode all along?
All about to find out.
If this turns on with the diode after I made you replace that, you get to punch me in the face.
I mean, the
deserve
SMC did get hot.
Yeah, but that,
Oh, it turns 20 instantly.
you son of a bitch.
But we still get no.
Okay, turning 20 instantly is still progress.
Yes.
What if the original SMC was good, but now we put a bad SMC on the board? That would be hysterical.
0.4 PP bus.
Yeah, basically it was an Oh well. You continue thinking.
No, I don't want to solve 0.4 PP bus. That isn't the ISL 9239. Ah. Fuck. What could it possibly be? Check rails one by one. How am I gonna check rails one by one? I know which rail I'm missing. Ah. All right. Where is you? PDF. Did we kill current sensing? R7020. So this guy is still good. And you are still good. Why do we not have PP bus? Does it have an enable that I'm missing? Oh. Shit. Is he gonna bite me in the ass, isn't it? Yep. Ah, stupid magnets. Okay. Nope. Okay. Now this guy goes to there. Gonna do something stupid here. You guys can't see it. Alright. So I'm just gonna see if there's continuity between those two guys. Because I feel like I did something stupid. So I'm just gonna press it down here. See if I get a reading. Okay, so I am being pressed on it. Cool. I gotta find the resistor on this side of the board, which should be you. Okay, so again, press you down. Do I get a reading? I get a reading. Cool. So if I touch this guy, Tim Cook, why doesn't this work? This is gonna pull. I can't do it. This is too advanced for me. Ah. We tried. I tried. Lewis tried. We all tried. This is why Paul has a queue. Darn. We've almost had it, guys. We were so close. At least we had some progress done. This is a very hard board. Lewis got it to take 20. I got it to take 20 quickly. And now Paul's going to make it turn on. Tune in next week as we get a MacBook fixed live on camera. Thanks for all thank you guys for tuning in. I'm sorry I couldn't fix it. I'm sorry Lewis couldn't fix it.
20 volts?
0.4 still.
What? Okay, do you have
I have SCL. I have SDA but not SCL.
What's SCL stuck at?
100 millivolts. No signal.
Okay, so one of those three is bad. Wait, so what happened with the diode? Because you said you knocked the diode off.
Oh, I replaced the diode,
Huh?
and then I got my SDA working, and it takes 20 volts normally, but I'm still stuck at 0.7. PP bus and SCL is not existent.
If you remove the PMIC, does that go back up to 3 volts? Remove the PMIC.
Don't give Paul a hard time.
What do you mean? You're putting this back on. Remove the PMIC.
No.
You just take it off.
What does the PMIC have to do with anything?
Take it off. You never had a grown man stare at you and tell you to take it
Well,
off before?
if I take off PMIC, it's not going to turn on.
It's going to at least give you 3.3 volts in SDA SEL, which tells us that was one of the issues.
Are you
Or it's your SMC is bad. It's one or the other.
This is from a known working SMC.
Okay, then take off the PMIC. You're just making a better argument for moving the PMIC. Take it off. Everybody in the chat would love to see you take it off, I'm sure.
Fine. Where are you? There you are. Okay, fine. Usually SMC and PMIC are in cahoots, and if one's bad, they're both bad. Blah, blah, blah. Wah. I'm Lewis Rossman. I fix boards. I want to go to school. I don't want to be here. Where's my tweezers? They're lost. Oh well. Screw it, I got this thing to... Oh, sorry. Alright, let's remove this thing. Let's get it over with. Shut up, Oran.
Take it up now. Take it up.
Ah, you bampy man. PMIC is removed. Then we're gonna wick it so it doesn't short anything. Okay, then we're gonna chop off this piece. We're gonna wick it again. I had too much solder on my wick. Alright, screw it. Q-tip. Oh shoot, there's one missing. It's probably not connected, but spooky nonetheless. Let's find out if that's not connected or not. Bum bum. 1, 2, 3, 4. Unconnected. Yes! We out here. Okay, so let's plug you in and see if PMIC was the issue. I don't know what happens if PMIC is not even plugged in. Let's see, do we even get 20 volts? We have 5. We have 20. Oh, whoa, whoa, wait a minute. Oh, something burned. Something smells smoky. I don't know what, though. Uh-oh. Yeah, this board's dead, beyond dead. Hey, Lewis.
Is VMT a word? There's no vowel in
Do
there.
you come with subtitles? Do you know what happens when you turn on a PMIC? I mean, turn on a board without a PMIC?
What?
It takes 3 amps and something smokes.
Seriously?
Yes.
What's mo-
I don't know. That's the problem.
Oh, because when you take off the PMIC, now they're... Okay, some of those buck converters are not using a PNP. I think it's NPN N-channel transistor, so that if they get nothing, they just... No, they're using P-channel transistors, so if they get nothing, then it just puts out full voltage to everything.
Oh, so...
Let's see. So what's smoke? Show me what's
I don't know. The board just smells smoky. Yeah. It took 3 amps.
Where?
I don't know.
How fast did you unplug it?
As soon as I saw 3
Replace
amps.
PMIC.
Replace?
Yeah.
But
Continue.
continue.
Yeah, continue the easy board you gave me.
Okay, $2. This board is a nightmare. Yes. So, are there dead transistors? I gotta find out what fucking blew up. Come on, guys. Help me find something that exploded. Wait, do I... Nah, I can't smell the burning anymore. That would have been like a dead giveaway. Darn it. Oh well, PMIC replacement time. Fun. What time is it? 5:02? Okay, I'm gonna replace this PMIC, then I gotta go to school. How about that? I don't care what the outcome is. I'm gonna be late. I'm gonna be tardy on my first day of school, guys. Okay, so, donor board. Fuck it. Don't care. Gonna speed run. Lewis, I gotta go in 30 minutes.
Go where?
School.
That's a really fast reballing.
I'm gonna, yeah.
You have to get it right the first time.
But I don't know what blew up.
Well, you give us a call.
Yeah, Paul's good at figuring out what blew up.
Paul loves fixing problems like that. He's probably watching this presentation right now.
You can't leave until the job is done. This came in as a no fix. This came in as a no power. It's gonna leave as a no power. Come on, PMIC, come off the board so I can go to school. 5:03. We got 27 minutes left. Any second now. Yoink. Oh shoot. Come here, mofo. It's stuck on the ground pad. Ah. Oh, it's stuck on CPU. All those balls on the CPU, dead. Okay, donor. Next, reballing station. Ugh. Focus, you fack. Clamp in place. Wick the pads. Let's go, let's go, let's go. I can't wait to get out of here. Yes. Okay, Donator Dolly, I know you just want to be done. You're learning from everything you do, regardless of the outcome. Lewis is not doing you a disservice by making you continue. He's making me do my job, yes. The thing is, he's making me go down a rabbit hole that may or may not be fixable. And what they tell me, as a business, you don't, when we have 100 machines that need to be fixed, you don't spend 3 hours on a machine you don't know what's wrong with it. Yes, it's nice to learn what's going on, but this is a very, strange anomaly that this is not taking. Usually if you don't have PP bus, it's a bad ISL or your PP bus is shorted. Who's knocking on the door? What? Anyway. But if it's not that case, then you have to find out why it's not, and usually, no one knows why, and you gotta figure it out. But would you rather figure it out and spend 3 hours, or fix 3 boards in those 3 hours and make $1,000, and this is gonna make you $400 if you can find it. If you can't find it, it ends up a no fix, and you just wasted so much time for nothing. You're just looking at things through a realistic perspective, and that's my take on things. Alright, so let's get some Captain... I don't have solder paste anymore. Shoot. This is a really good stencil. To the guy who said, if you know what the issue is, then you'll know every time. But the thing is, this is such a strange board. This is so rare that, like, out of I started in February, so March, April, May, June, July, August. Out of my 6 months working here, that's over, like, probably, actually, we have ticket numbers. I joined when we were in, like, the 23s. Yeah, 23. We're up to 27. We've had 4,000 MacBooks come in here, and I've only seen this issue twice. Alright, that's how rare this issue is on a MacBook. We've only had PB bus not present from not a short and not the chip itself twice. Okay, I gotta get a new can of thermal paste. I'll be right back. Step aside, I need to get to the fridge. Yes.
Don't make Kevin rage like that. So we grab our new thermal paste from store.rossmangroup.com. Awesome. Not awesome, it's already leaking. Oh, no, microscope, my fault. Oops. No, I gotta replace PMIC. And then school.
What time is your class?
6 o'clock. But it's in Brooklyn. Can I borrow Buffet?
You want?
No.
You can ride it if you'd like.
No. I don't have a death wish yet. The last person to borrow Lewis's Buffang broke his collarbone. I think he has a video of it too. We saw the video, it was funny. He like borrows it for 2 seconds, falls down and straight up dies. Okay, let's grab all that excess out of there. Grab a napkin, clean that off. Get a nice little wipe. Set a nice little wipe. Alright, we'll use a fucking Q-tip. Wipe off all that gunk. And speed run PMIC placement begins any percent. I know, what are you doing? I'm reballing a PMIC. Now watch as these balls melt. I said melt, damn you. Alright, they're all melted. Wait for it to dry and remove. There we go. One fell swoop and it's there. That's what I was trying to do from the beginning, but it didn't work out. But now we have a PMIC completely reballed. Let's put that on the board, call it a day. This is not going to turn on. I know something's going to short and blow up. Because we already know something on this board took 3 amps and blew up. So we're going to go back to our board right here. Da-da-da, there you are. Refocus, re-brighten, refocus. There we go. Top left is our chip. Now we're just going to add a little bit of flux. Let's try again. Now, before I turn this on, I'm gonna put on Please Bro and see what fucking blows up if this happens. Ugh. We know the SMC is fine. We know the CD3215s are fine. I'm just so confused on what is not fine on this damn board. Press you into place. Right about there. It's in place. Now let's roast this mofo. Come on. Well, it's not in place. It's not in place. It's not in place. It's not in place. Too much flux. Ah, I'm panicking. Stay. There we go. Okay. There, flew into place. Give it a little nudge. It's in place. Fuck this board. This board can go fuck itself, okay? I'm done. I hate it. Sucks. I want to go home. Nah. This has a dead CPU. Why even trying PMIC? Tim, you missed it. This didn't have 3 volts. Lewis fixes it. Had 3 volts. SMC was bad. Replaced SMC. SMC diodes were bad. Replace that. What do you want? No, I need that. I need that. No, no, no.
I want your tears.
No, no, seriously. I need it for like 10 seconds right now. I'm sorry.
9. 8.
This board took 3 amps and blew up, and then I replaced PMIC. Now I gotta find out what
Why
if
did
it.
take 3 amps?
I don't, because Lewis said remove PMIC and see if it turns on.
Oh.
And then he's like, oh yeah, the MOSFETs that end up closed don't close, and they just stay open, and you know, everything takes full power.
It's dead. Give up.
No.
After the next
Yeah, absolutely. Okay, let's see. Bop. 20. No blow up. Cool.
20 and 0?
20 and 0.3. I've never had PP bus on this. But
Did you knock the cord out? What's finicky?
not the charge port. Bam. 0.6. Nothing's changed. And nothing on this board gets remotely hot. Screw.
7,000, 50 meg, whatever.
Screw you, Lewis. I'm going to school. It's all yours.
Alright. What class you got?
I have no idea.
Cool. Well, have fun.
Yeah. Time is it? 16-minute PMIC. That's not bad. Goes back to Lewis. Screw this. Bye. .7. Wait a minute. One sec. Fucking mic. I don't care, you guys. Schematic board view. Gonna kill Lewis if he finds out. Where's the other half of my board view? You are. I don't have it. There's no. Oh yeah, because this is different and dumb. Where's 3, 4, 2? You. This can't be you. Can it be you? Can I blame you? Do I blame you? Let's blame you. Let's play the blame game. Turn on, please. Cross my fingers. Oh, you're not even on the board anymore. Did I break it? I broke it even more. Fuck. Really? Cause fucking, god damn it. Why are diodes so fragile? Blame you. It's not your fault. Sorry, I thought it was your fault. You're an actual good diode. Put a dead diode on a board to troll Paul. Paul's gonna hate me. Paul's gonna hate me. Gonna go. Thanks for it. I gotta go to school. I'm done playing with this board. Just magically turn on now.
What are we still doing? I thought you were putting this in the Paul's queue. You have the college to do it.
Yeah.
Put this in Paul's queue as an easy, easy PPFG3 hot missing. Because I need my computer back there. God bless you. Go on to college. Go get an education. Alright, so this board will be continued to be worked on by Paul S. starting tomorrow. As in, somebody asked if you're Turkish.